The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, December 29th, 2022. This will be our last update of an exciting year here. And the long and short is that both of our volcanoes, Kilauea and Mauna Loa, are not currently erupting. They've both been glowing still a little bit, and that glow has been dwindling over the last couple weeks here. In short, Mauna Loa is not showing any underground signs of any resumption, anything like that, and Kilauea kind of is, with magma still coming in and earthquakes and some deformation happening there. That's the quick version. We'll do another shorter visual quick version coming up, and then we'll go through the details. How you doing today, Dane?
Oh, good. Yeah, some interesting stuff going on. I mean, coming to an end of the year, I mean, we had basically a year worth of Kilauea eruption and just fell short just shy of the finish line. But, we're still in that pause phase, technically. But, yeah, not a whole lot of action over the past 2 weeks. We took a little bit of a Christmas break there. Felt like it was timed well. And now we're back and go over what we missed and try and talk about some, anything that's new on the volcanoes that's come up.
Right, yeah, and so we'll keep at this perpetually going into next year, and we'll keep going every week, and unless things get really quiet for really long, then we'll kind of back off a little more. But that's our plan, to keep at it, and as we go through and the volcanoes don't exhibit signals, we'll talk about the history and the context and all of that. But for today, we're kind of going to focus on more what's happening for the last couple of weeks and the kind of end phase details of both eruptions here. if they are in fact over, right? Mauna Loa seemingly so, and Kilauea perhaps not, depending if it hits that 3-month window or not. Wait and see. So interesting times here. Get into it, Dane. Unless you got anything else to add.
No, that's about it. If anybody does have any questions, go ahead and drop them in the chat, and we'll try and cycle through those and get them to you. Get some questions fed to Philip at the end. I might be able to answer some as well in the chat. So yeah, be active, and we'll try and get anything answered in there.
Yeah, mahalo, Dane. All right, so what I have playing on the screen for you guys is just a little clip of the last few days of Kilauea. This is the V1 webcam, which has been repositioned on the 27th, a couple of days ago. And what you can see here is that there's still a little dot of red in the middle of the screen here, and I can zoom it in for you guys. So you can maybe see it a little better if you're not looking on the best device, but there you go. That's zoomed in. There's that central island that's in the middle of that crested lake. And this is not exactly the same spot as a recent active lake. Let me just pan it over a little bit and show you guys over here. This is the area over here that was the more recently active lake. Get my cursor correct. So right over here, this is that zone right there. And across on the other side of this central island, near the center of the, more towards the center of this crusted lava lake is where we're seeing this glow. This is a place we've seen glowing even during the last few months of the eruption. Interesting to see it activate and be the more dominant spot now. That's the long and short of Kilauea as far as how it actually looks, which means there actually is still glow to see from time to time. It's not necessarily the lava that was circulating in the lake as it was before. This is on the viewing overlook side of things from the national park for the Koi and for the Kupina Ipali, but it's definitely not as big an area, not as strong as before. Still, I always thought it was exciting when it came here even 30 years ago, and I could even see a little spot of glow, so I still count that as cool. That's what it looks like visually. And as far as a graph to show you is summarizing Kilauea here. This is earthquake rates over the last year. And you can see that there are earthquakes per week here, and there was a larger surge that happened back at the beginning of the year in January. And overall, we've had fairly constant low levels until just recently within the last month. And it's not elevated a whole amount, a huge amount here, but you can see that it is certainly a little bit above the background level that we had previously to that. So a slight increase, nothing alarming, but it's just showing that the magma is accumulating underground still coming into Kilauea here. That's the shortest version, in case you don't have a whole lot of time to stick with us through all the more esoteric details of these eruptions. So turning to Mauna Loa, I'll show you this little clip, which is from the M7 camera. And it's showing the saddle road cars flying by here in the bottom, but also it's showing this flow front that's back in here of the front of the Mauna Loa flow. It moves around a little bit here because of the wind and stuff. But hard to exactly see, but this is going back to after Christmas Day. If I zoom it in quite a bit, maybe I can find the spot that somewhere in here, which is periodically putting a little pixel of glow, and I can't seem to find it at this speed. Back it up. But it has been glowing a little bit, really in the last couple of days since Christmas, and it doesn't seem as obvious here in the last couple of days, yesterday and today. But down on the flow front of Mauna Loa, still a little bit of glow and a little bit of settling happening, as we'll show you in the webcams in a little more detail. I'll find that in the next sequence here, but that's maybe the point. Kind of hard to see. It might be there, but very small and localized in different areas. And as far as a graph for Mauna Loa, here's the tilt plot for the last month. And we've just passed the 1 month anniversary of the beginning of that eruption. So that initial signal that went really high up and dropped back down, all that's scrolled off the graph, which is nice for us in this particular case because we now have a more reasonable scale to look at the tilt with. So here we have 30 microradians down to -15, which is still a pretty big threshold, and that's mostly accommodating for this earthquake that occurred back here on the 6th toward the ending stages of eruption. This is was the beginning of the end there. And the blue line is what we're looking at here, focusing on today. That's the tilt towards that summit caldera from the top station here at Mokuaweoveo. And it came down, and then after the eruption ended, or even before it ended here, you could see it started to re-inflate. And as we noted a couple weeks ago, it started to turn over and get flatter and flatter and flatter. So the story really for the last couple weeks, as far as that goes, is there's a tilt today compared to what it was 2 weeks ago. It's slightly higher. Seems like it rose a little bit, it dropped down a little bit. There was a little bit of a gap in here because of the high winds and winter storm interrupting those communications. And we can still see the pattern of the daily cycles coming back in here at the end with a very slight rise. So very, very slightly inflating still, but this is normal for Mauna Loa. In case you haven't heard it say it before, it's the same pattern that we've seen after the 84 eruptions and the 75 eruptions too. The biggest difference being that we have better resolution. We're getting data every day now, whereas in the 84 and 75 eruptions, we know that a long-term trend was for actually a couple of years having an inflationary pattern present on a volcano after it erupted and after it was then erupting. So it could still inflate for a while and be within a normal range of post-eruptive background, and that's where we find ourselves now. That's just the inflationary part of it. If you were to expect more activity to renew up there, what you're really looking for would be more earthquakes and maybe some sign of gas. We might have to have an open pathway for the gas to get out now. We're not seeing any extra gas come out. We're not seeing any earthquakes. So it really does seem like it's wound down there. And we do have a volume from Mauna Loa's eruption for 2022, and so what we'll do a little bit later is put that in context of how it compares to Kilauea and how it compares to other Mauna Loa eruptions in a broad scale as we kind of round out the post-mortem on an eruption here a little bit. And then obviously we'll have Volcano Awareness Month coming up next month, and there will be more talks in Mauna Loa, more talks in Kilauea led by the USGS, outings out and about various parts of the island. So we will cover that at that point and get into the details further then following the lead of the USGS. So that's the summary from Mauna Loa for now, and that's, if that's really all you need to know, then thanks for joining us. But if you want to hear all the details, which I imagine you do if you're here, then we'll get into it here. So starting off with Mauna Loa, let's look at the actual observations that we have. So let me start with the updates, actually. So the USGS updates are our primary source, and their cameras and instruments and all that. Mahalo to them for sharing everything online. So the update we have, I'll start with last week's since we skipped last week, and it's fairly similar to this week's. And in long and short, the volcano is not erupting. Last week, there were no signs of activity on the northeast rift zone, with weak residual incandescence visible intermittently from the flow front at night. No active lava within the caldera or either rift zone, and imagery shows the entire flow field cooling and no longer active. Seismicity is low, and there is no detectable tremor, which is what you'd expect to see if there was magma coming in. Calling it subsurface fluid movement, right? They mean magma there. Deformation rates have decreased significantly, and there's no sign of inflation at this time. We continue to monitor, and we expect additional shallow seismicity and other signs of unrest to precede any future eruption if one were to occur, and if it were to continue somehow. Otherwise, SO2 gas emissions are background levels, and everything else is pretty standard language here. You get a big summary, historical summary here, but that's the update from last week. And following the one from this week is very similar. This is from earlier today, 7 a.m. And they say webcams show no signs of activity, site of the eruption. Weak residual incandescence may be intermittently visible from the flow front at night, but it has not been apparent in webcam views over the past several days. And everything else is the same as I just read to you, so I will not repeat it. So visually, looking at the MK2 camera, this is a camera on Mauna Kea, looking across the saddle to Mauna Loa. See, there's been still a scattering of snow in the upper part of the mountain here. That's this white stuff on the top right. The eruption site is right in here. Vent Fissure 3 at that 11,500 foot elevation. I'll take my red cursor off of there so you can really see there's nothing visible, no gas, no glow, nothing visible from this distance across Mauna Kea. So the vent appears to be fully quiet and stopped glowing, and if anything, you can start digging and you might notice a couple pixels down here in this area of the flow front. This is hard to see there. That's what we'll pull out that M7 camera, and I'll play this a little more clearly. So here is going back for 2 weeks ago. You can see the flow front, lots of glowing spots in here. The cars going by, and maybe I'll zoom it in at this point so you can see a little bit. There's those little red spots, and you imagine the center of this lava flow that we've heard can be up to 40, 50, 60 feet thick in the middle. It's still pancaking out, and the very edges are still getting pushed and settling, and that means that the interior gets exposed or be glowing. You see the rocks settling and tumbling over, occasionally putting up little dust clouds. The animation now is going through that windstorm and getting jerked all around. I may have to zoom it out a little more here, but you have to deal with the weather, of course, and sometimes you don't see the glow because of the weather. But right in there, there's a spot right in there. Right in here, a little glowing spot on that flow front. And occasionally you see a little dust cloud come up right next to that. So looking at the camera, I saw this as recently as Christmas morning. You could still see a little bit of glow on this flow front. And whether it be for the distance of the cameras, lack of resolution, anything else, it's not been visible since then. But I have seen a couple of these little dust clouds coming off the flow front as well, so I do think it's still ongoing at low levels, but maybe it's cooling off at that edge where you don't see it glowing as much anymore, but it's still settling, and you might see a little bit of dust and steam coming off the front. So that's the visual Mauna Loa. Yeah, go ahead, Dane.
Yeah, just thinking about this this glow thing, because it reminds me so much of 2018, chasing the glow then, right? Trying to capture the glow is one of the things that we were having issues with then, being able to see something with an exposure that you wouldn't see with the eye, or conversely, not being able to capture something with a camera that you can see with the eye, right? And
Right.
yeah, it's to me, the thing that jumped out immediately is that it would be a somewhat significant glow there, like not just some small little trace glow that we're able to pick up. In 2018, it had to be somewhat significant in terms of there actually being something there.
Right, so 2018, we still had that pit inside of Ahu'aila'au Fissure 8. And down in that pit, it seems the lava was down in there, and it had a path to glow to the clouds above it, right? And we eventually did see it rise up that shaft and fill up that hole and make a little pad on that crater floor, or cone floor, really a crater there. And we're not seeing that now, so that's a good point, right? So I mean, if we're not seeing the same pattern. Even now, it seems like it's shut off much more quickly, came on quickly, shut off quickly, and no signs of any further action happening here. And as USGS has said, and just about all but one previous case, which is still arguable, the eruptions on the Northeast Rift that have erupted in similar fashion, when they end, and that's the end of that. That's still our expectation, unless we see anything different. Obviously, we have a very short human history compared to geologic time, so it can do something we haven't seen evidence for in a surface here. But our working basis is that unless we see something really unusual come up, then it should really be over at Mauna Loa.
Right.
So that's the visual part of it, and I did want to bring up this Earth Observatory article from NASA, Seismic Mauna Loa's lava flows, that was few weeks old now, right, from December 7th. And those of you following us have seen us share this graphic of the flow extent here, and colored by thickness as well, put out by NASA. And since this is a little bit of old news, I just want to focus on a few things here. You can see how much thicker the flow is down here at the flow front, and thinner up at the top, but really that whole mid-channel level all the way down is what's showing the reds right in there. And I can make it there. So see, these redder areas are the thicker areas coming all the way down. And by comparing the elevation and ground surface before and after, they can come up with the volume. So let me scroll down to the part of the article so I can show you this here, and we'll elaborate on this further, and we expect this will be part of the USGS presentations next month as well. But their result here, over the 14-day eruption, Mauna Loa erupted more than 8.8 billion cubic feet, or 230 million cubic meters. Right? This is about 66 billion gallons is the other way to put it out there, since we've been talking about gallons, and we're talking about Kilauea as well. So 230 is what we'll be working with in cubic meters, since that's the more easily comparable number to all the publications. And one other stat here, let's see, where is it? Up here, maximum thickness of roughly 25 meters, 82 feet is shown. The values exceeding 40 meters or 130 feet were observed in some areas. So if you're wondering how thick it is, that maximum thickness of that pad might be closer to 80 feet in the middle of that pancake pad of lava at the bottom of the hill there. And potentially up to 130 feet, depending on exactly where. So those are probably two of the key questions, and this is one of the numbers I was waiting for to try to tie things up here. So maybe quickly we'll do that here, and I'll do that by first showing this graph that I showed a couple weeks ago. This is upper panel looking at Mauna Loa eruptions, and so here's magma volume in cubic kilometers. our number would be 0.23. However, this bottom panel is Kilauea, so we'll ignore that one here today. But however, let me zoom it into here so you can note this note here. Eruption volumes are converted to magma volumes in cubic kilometers, assuming 20% vesicularity. So this is a little nerdy detail here, but that value that's put out at 230 is including all the bubbles. And often geologists like to standardize things because bubbles can vary from eruption to eruption, place to place, all that. So you'd rather compare the magma volume rather than the full volume, including the gas. And that's why they're doing this 20% vesicularity number, right? So for example, the 84 eruption of Mauna Loa came out at 220, just under this eruption, 220 million cubic meters. But it's plotted on here as somewhere around 0.18, right? So 180 or so because of that volume difference. And so likewise, our eruption here in 2022 would be just slightly above that, but it would look like something like something like that, right? In the scale of things, similar to 84, slightly higher. And if you look back at this plot in time, this is all eruptions in Mauna Loa. You can see that line, if we draw a line across around an air, there's only a few eruptions that actually put out that much lava. And the most recent one was 1950, and that was off the Southwest Rift. This chunk in time here was a long-lasting summit eruption. You have a couple other Southwest Rift eruptions. It's really you got to go back to, if you want to look at the Northeast Rift itself, this is the largest eruption in the Northeast Rift back since 1855, 1856, which is a long time, right? And if you pick out 1950, you go back to 1877 before the next largest eruption. So really it was one of the larger ones, and maybe this relates to the fact that you're having much longer intervals between eruptions here, right? As opposed to more frequent pattern you saw back before 1950 and after 1840. Maybe you don't recharge it quite as much, but you break it open more often, and so maybe more frequent lower volumes. But that is in fact the pattern that we're learning from this eruption here, something like that, right? So that's how that compares in the history of Mauna Loa. Interesting, right? Especially when you start looking at Kilauea, right? So Kilauea, here's a plot that we used for a while, comparing 2022 back to 2 years ago in 2020. The first eruption began December 20th of 2020. So we've had actually a full 2 years, and we'll come to share that December 20th, 2022 was the last lava overturn in a lava lake that we saw at Kilauea. So 2 years to the day, it seemed like, lava on the surface. But you add up the first phase of eruption in 2020, 2021, that was 41 million cubic meters. And the phase that just came to an end here recently, that's 111 over here on the right. So together, Kilauea put out 152 million cubic meters in 2 years, right? And 152 over 2 years compared to 230 over 2 weeks. And this maybe reinforces what we've said for a long time comparing Kilauea and Mauna Loa, which is that Mauna Loa puts out a lot more lava in a lot shorter time, right? So that's really evident there. It's hard to compare it like as far as a daily rate because Mauna Loa was active much higher rates for a much shorter time. So it comes out to something like 80 times the daily rate. But really, depending on how you bracket it, you could do it by year, or by a couple of years, or whatever else. Even over 2 years, right? Mauna Loa being inactive most of it, Mauna Loa has outpaced Kilauea. So, and another way to look at it is you have 50% more lava. So Kilauea was 150. You add 50% more, you get to where Mauna Loa was. So 1.5 times Kilauea's eruption, 50% more, is what Mauna Loa put out in a 2 week period. And that's why we take Mauna Loa really seriously, right? I've in the past heard Kilauea described as the Goldilocks volcano. And Kilauea is big enough to be interesting and dangerous. A growing volcano, like a teenage volcano going through her growth spurt, and can really do a lot of damage, but a lot of times is still learning, establishing herself, her systems and all that. Mauna Loa, being an adult, full-grown volcano, can do a lot more work in a lot less time. And that seems to be reflected. So we do have this historical activity table. I know you probably can't read any of this, right? But, you know, this is the table that's on the USGS side of all eruptions of Mauna Loa, and there's 2 columns of interest, a year over here, and total volume is this column all the way on the left. So without looking at the years, I can see how much I can zoom this in, right? But See, our number would be 0.23, so there's 84, and if I scroll down, you can see that's 1950 right there, and then everything else lower, lower, lower. Scrolling back in time, a lot of the eruptions in Mauna Loa are a lot lower volume there. I need to go back to this one, 0.44 and 0.63, these two. That was submarine eruption, radial vent Kilauea, summit eruption, summit caldera up here. I'll scroll it back down some more. Here's another one, 0.38 and a 0.28. So that was a radial vent north of the summit back in 1859, and then here's an eruption from 1855 to 56 that lasted 440 days off the northeast rift, and in that time we would put out a larger volume of lava. So really that one exceeded us in volume but not in pace. And going back further in time, that's the end of the catalog there, right? So this eruption was pretty noteworthy, right? It makes it the 6th largest eruption in Mauna Loa since 1832 that we have on record. We only have so many of them, of course, but that, in that time frame, including all the radial vents, including all the summit eruptions and all of that, is still the 6th largest, and maybe the 2nd largest on the northeast rift, although potentially at a higher rate here. So I was hoping to make some graphs of this, but I'll have to do that for next time. I didn't quite get to that this week, but hopefully that comparison works for you guys there. So let's switch to a little bit of the monitoring information from Mauna Loa here, and starting off with a tilt plot for the last week. And the pattern here is generally one of a rise. That's the rising trend you see there. And you see these daily variations still occurring. That's normal background from Mauna Loa. So not a whole lot here. We're starting at somewhere around minus 0.5 and ending at maybe 1.5. So something like that. It's rising, still rising slightly here. And in a long-term pattern, that's what we showed you guys to start. That's this piece of the graph right in here. And so you can do that for a while, as we noted before, considering 84 and 75 follow-up. And maybe more appropriate to compare the 84 and 75 patterns to the GPS plot that we got, because they actually were having to go up there and do the measurements by hand manually every time. And GPS is doing it once a day as opposed to continuously every 15 minutes or so here. So the pattern in GPS should likely also reflect this, even though it's mirroring a deeper signal. It could detect that deeper source of intrusion into the volcano, and the tilt is more sensitive to the shallow stuff. You'd expect that the shallow stuff would eventually flatten off, and you'd continue to see the deeper stuff still active. So there's a pattern going up, which shows that two sides of the crater are still moving apart from each other there. What this line length across summit caldera of Mauna Loa is. There's also the up signal at the single station there, and you can see that after that eruption, it's coming very slightly up here, but it's really not coming up nearly as fast as it's still settling and sprawling out there. Right, so interesting to note that it likely is being recharged with magma still. We think that the pattern we're seeing underneath Pahala, which we'll mention briefly, a lot of you guys are talking about a paper that came out this past week. The pattern of seismicity in Pahala is showing that the supply of magma to both volcanoes from the hot spot is still very healthy. So magma is likely still coming in. It's more a matter of it's already relieved itself of much of the pressure it built up for the last couple of years. And now it's in that recovery phase. And so likely it'll do it again, especially if this input rate from below continues to be healthy. And when we see this change and these patterns change to be more steep, then we'll look at that more imminently. But for now, everything looks normal within that pattern that we see in following eruptions in 75 and 84. So that is Mauna Loa monitoring, and we will switch to looking at earthquakes. However, the Volcano Watch last week does discuss earthquakes, so we'll jump briefly into that as we discuss earthquakes here. And not to go through this entire write-up, those of you guys who are interested can find it on hawaiitracker.com, among other places here. But a couple of things I wanted to pull out from here. Right? So they're talking about how earthquakes are useful to monitoring volcanoes and how they can be used. And I like this analogy they put in here. As an analogy, think about the different sounds that you hear when you turn on and use a garden hose. First, there is squeaking when the pressure first builds up. Then as water pushes on the air within a hose, there are gurgling and crackling sounds. And finally, there's a steady humming as water streams smoothly out of the end of the hose. HVO, or seismic instruments, are our ears as we track the magma within the volcanoes and the lava as it erupts. So that's another good analogy worth pulling out for you guys there. And in that context, we're not hearing any humming or anything else. There's no sound at all coming from within that volcano now. So some of the background here that they put in here, but what I wanted to highlight here, see here, was this little bit right here, right? So HVO's current capabilities allow earthquake detection and location to levels far surpassing those of 1975 and 84. Better compare current earthquake patterns to these previous eruptions. Seismologists hand-counted tiny earthquakes in September 2022 that were too small to be recorded by modern computer processing. Right, so let me emphasize this here. Too small to be recorded by modern processing means they're not showing up on our earthquake plots. This is not something that any of us saw. They're not showing up in our earthquake counts that we're looking at from USGS data. This is all something that they're pulling out by hand, these micro earthquakes. And so we haven't seen this data yet, but it's that comparison that showed a similar uptick in activity and led to the meetings in the ensuing months to emphasize awareness, preparedness, and safety. So we suspected there was something else USGS was seeing behind the scenes that was leading them to step things up besides what was evident on the public-facing data. And here they're sharing that it was these micro earthquakes were that trigger for them, in fact. So that's also connects to the micro earthquakes of Pahala that were counted in this other study. But the long and short of it is that we likely will see the USGS and other agencies tracking micro earthquakes counts in the future as another means of monitoring activity in the volcanoes, and that's another important tool to really emphasize and not just micro earthquakes anywhere, but in specific parts of each volcanic system, which is where that study comes in handy. We'll get to that here shortly. So that's the volcano watch from last week. And having said that, let's look at the earthquake maps. So here's the earthquakes for the last week on Hawaii Island, and there's Mauna Loa, and you see nothing around the summit, Northeast Rift, a couple of these events kind of surrounding. And in contrast, you do see Kilauea still have quite a few, and Pahala still has quite a few as well. And so we'll talk about Kilauea here shortly, and Mauna Loa, we can kind of close the book on that. We'll discuss Pahala a bit as well. But since it's been more than a week, let's come back here, and I want to change my settings and show you the last 30 days. Unfortunately, that's going to include that whole eruption in Mauna Loa. Well, not the whole eruption, right? That post-initial phase of the eruption. And so you see that how that relates to the yellow dots that are what we see now. But I also wanted to zoom out a little bit here because there was another earthquake that occurred a little bit unusual over here near Maui. So let's look at that one. That was a 4.0. 30 kilometers depth, and that's not one that we usually talk about, but the USGS now has this 4.0 threshold that if something exceeds 4.0, they're going to put out a statement. So we did have a statement issued by the USGS on Friday, December 16th. That earthquake that occurred 19 miles south-southwest of Hana at a depth of 8 miles below sea level. We revised the depth here on between the catalog and here, the depth is inconsistent, but in any case, earthquake had no apparent impact on either volcanoes. It's likely related to crustal readjustment on Haleakala volcano and not related to volcanic activity. So it's worth mentioning that. Nothing really more to say about that, but it did occur there. And pulling it back, not only put it just to the last day, so you can compare it to, as you guys have been following us through the whole 2022 eruption. Oh, that didn't work, did it? One day. There's a last day of earthquakes, and so there's nothing on Mauna Loa, only one on Kilauea, and Pahala is still doing its thing over here. So now I'll mention, I won't go into this in too much detail, but there is this paper that is out, Magmatic Web Beneath Hawaii, by John Wilding, Wei Chang Zhu, Zachary Ross, and Jennifer Jackson. This is a group out of Caltech, and they are emphasizing the magmatic web aspect of it, right? So essentially what they've done here, and I'm not going to go into super detail here, but I want to show you guys a couple of things. But essentially what they've done is leverage advances in earthquake monitoring with deep learning algorithms and created better images of the structures underlying the earthquakes in Pahala, right? So we've talked about for a while that there was a new deployment of seismometers above ground in Pahala. This is not that study. This is a different approach to looking at that same issue of we want to know what's happening underneath Pahala, because everyone has been curious and earthquake levels have been a lot higher. And this is a long and short of it here. This is the image they've produced. They have a whole 3D model of this, and I'm not going to go into that today, but as a whole, here is that deep source of the magma collecting in the sill complex underneath Pahala. And you see pathways that go to underneath Kilauea and then upwards, and they see pathways that go up towards Pahala and Mauna Loa. And they actually see not as well a pathway, but they do see some earthquakes that come underneath Mauna Loa, formerly known as Loihi as well, right? Less connected because it's not been as active as the other two within this period of study here. This is what we've talked about and seen for a while, and it's great to see it in greater resolution. As we dig into the details of this, there's some nuances that are worth considering as well, but the big picture is overall the same, right? That you have this pathways that exist from the hotspot up to the volcanoes, and they're calling this a web because they're actually seeing multiple pathways coming up to the volcanoes. And that's what they're emphasizing here, and how well connected the whole system actually is, right? Actually seeing an image of what could be thought of as a deeper magma reservoir connections up to both volcanoes. That kind of breaks the idea we talked about before. These volcanoes are not connected by magma. We've talked about the pressure connection, but really when we talk about the magma connection, we're talking about within this upper part of the Earth here, right? And that's now something we need to reframe and make more clear as well. So that's the big picture. You see the green earthquakes are the shallow earthquakes that are the south flank of Kilauea and Mauna Loa moving. That's the relative depth of those things, and you see how the magma pierces up through that, and magma likely connects into those zones as well, and probably is getting involved there in that lubrication and movement of that south flank as well. So that's another one of these connections that we've heard speculated before, and interesting to see that relationship come up spatially here once again. That's one image. Let's show you guys another. This is a couple of views. This is a map view up here on top. Map view, and then down here is a cross-sectional view, a slice through. So this is depth going down. This is really far down, 36 kilometers down to 43 kilometers down. This is that 25, 30 mile range. And what's not as evident on map zone here, all these different color clusters, if you look at this zoomed in and cross-section, you can imagine that mantle source is bringing magma in, but it's actually collecting in these blades that are discretely evident through seismicity and separate, and you can see magma moving through them and sometimes propagating up the pathways and towards Kilauea or towards Mauna Loa, depending on the situation there. So untangling the details and the timing gets more complicated. We're going to leave that for another day. But from this image, you can see that they have a summary here of what they imagine this process, this whole complex to be. So down here is that hotspot source. You see tremor down there. You see magma coming into the sill complex. You see they're drawing multiple blades in here rather than one big blob like we've always done in the past. That's a new development here. They've imaged for the first time this connection that goes up to Mauna Loa by being able to more precisely locate the earthquakes. They have noted earthquakes at that base of the flank of Mauna Loa and up within a magma system. Mauna Kea, they've noted that seismicity is still ongoing. We've talked about that occurrence before, so nice to see them resolve that as well, and separate, not connected to anything. And likewise, you see this pathway coming up to Kilauea. And this one is interesting to talk about as well, going to the south flank area. But that's essentially the picture we've been talking about and sharing for a while. So in a big picture view is not a whole lot new, but in the details, there's a lot of cool stuff here that we can unravel as time goes on here. So since everyone's talking about it, I wanted to include that here a little bit, but that is as far as we'll go today, and we'll leave the deep dive stuff for another time. So we'll turn to Kilauea, since we've been kind of sharing that earthquake here, but before we turn to Kilauea's earthquakes, let's look at the visual observations that we have here. So let's transition to Kilauea observations. This is now the V1 camera, back from 2 weeks ago. So when we had those overflows of lava, repaving that innermost floor of the pit. And you can see they're infrequent, right? There's a 17th, here's an 18th, nothing happening at 18th, nothing happening at 19th. And then here comes the 20th, in the evening, we see our last burst and the last overturn of that lava within the pit there. And then days go by, you see gas is still being emitted, not at very high levels, but it's still coming out. Obviously some steam as well. There's been weather and rain and the storm and all of that. And what we see happen on the 27th, it's coming up still here, is that the camera gets zoomed out and repositioned. And likely it's because of what I showed you at the very top of the broadcast here, that new glowing spot that was evident here coming up around Christmas, maybe a little bit before Christmas even. And here's a zoomed out view, and there's that glowing spot that's now evident just adjacent to that central island. So interesting to note that. That's the visual history of the last couple of weeks here. Keeping it moving, here is that zoomed out view from the KW camera. So you can see that initial phase, and I'll zoom it in somewhat here. So you can maybe monitor this area that's fuming over here where the glow is going to appear. But this angle camera isn't as good as the other one, so you only see a little bit of it popping up behind the island. And you can see some glow from the west vent complex as well, the pond or vent area here as well. And there's a little bit of that glow popping up there. Hard to see on your screen, I'm sure, but I freeze frame it. There's a tiny difference and slightly less black right in there and slightly more orange. And so nothing extravagant happening there, but that's that big picture. And to show you the thermal camera, which is currently offline, the last 2 weeks, here it is, the last couple overturns. The camera, as it's adjusting its color scale here on the right, is cycling through some weird colors and flashes. It kind of resets itself once it sees real lava and can expand the scale. And as the flow cools, it turns more pink here, and then there's the 21st, and we really see nothing else until the 26th, which is the last image we have at present from this camera. So that is the thermal history there, and then it goes black here right at the very. One last view of Kilauea and its progress here in the last couple of weeks. This is a B1 camera looking from the opposite side, so that lava lake would be in a far background over here. That central island is right here. That fuming spot with the glow would be right there. So if I zoom it into that zone, you can see that spot glowing right there as well a little bit too. Well, not a huge amount, but this is a webcam after all, so you could potentially get that. If you're looking for those glow pictures, you might still get something cool at the national park, given what Dane was mentioning about the end phase of 2018, right? A little bit of glow. If you expose it the right amount, you can really see it light up and see some cool stuff. But overall, it's a pretty minor activity compared to the whole year. It's that viewing window is definitely not as good as it was before. So that is the visuals on Kilauea. Anything you want to throw in there, Dane? Feel free. Otherwise, I'll go to monitoring.
No, I mean, it's always good just, with Kilauea is always in a constant state of evolution. So even though there's not lava at the surface right now, just if you're, on island or, go and check it out, you can see something, get that perspective on it. So when it does change next time, right, you'll know what you're looking at. Because the real issue with this, when we're trying to broadcast all this stuff about the volcanoes, and it gets worse on Mauna Loa, is trying to represent the scale of the things we're talking about. They're very big, and when you see them on camera, they don't look nearly as big as they actually are.
Right. Yeah, absolutely. And having the baseline is important, and really, like, it's still fuming and still some glow, and like it's always a unique moment in time. You always see something really particular to that moment in time, right? And it's never going to be exactly that same way again. So yeah, that's why some of us live nearby and go and visit it often, is for that storyline for us to witness that and see it change and evolve. And so this phase is equally important for that. So appreciate that reminder there.
Right. And one of the things, we learn a lot in these periods, right? These are the periods really where we are able to learn, and also the eruptions where they're contained and kind of gentle. We're able to learn when we're trying to track the thing and figure out where the lava is, and and the pressure's on. That's not the great time to learn, right? We need to already have that knowledge with us by that time that it comes, and we got to be moving.
Right, right. And that's why when we're talking about these eruptions as they're happening and we say something and maybe don't go through the full thread of backing it all up, like that's what we're doing now and setting the baseline, and that's kind of where it all comes from, right? So when we talk about the history of Mauna Loa eruptions and the patterns and how they go and all that's what we're falling back on here, and that's what these times are good for sure.
All right.
So turning to Kilauea monitoring, let's put this on screen here. That's the last week of summit lava depth, and so the lava showing these daily cycles as well. I mean, well, I should say that the measurement of the lake depth is showing these daily cycles. It's not a huge amount. This is about 0.15 meters, 15 centimeters of of oscillation up and down. It could be the actual tripod that the instrument's on, or like the atmospheric conditions, or some actual movement that's occurring on that daily cycle. So we'll ignore all that if we can, and maybe we'll look at the high points of these peaks, and it does look like there is a little bit of settling happening here, and this is typical of what we saw following the first shutdown of the Summit Lava Lake back in May 2021. We saw that as gas was expelled from beneath that crust, the whole thing sagged a little bit and contracted a bit. So that's still a subtle signal. That's what we seem to see here. And looking at the last week of tilt, there's a jump happening right here in the middle, the most obvious thing. But apart from that, it's relatively flat on either side here. And this jump is attributed to an earthquake. There have been, in fact, several earthquakes that have been causing these little jumps here, and that's the story of Kilauea, is it's still quaking underground here. But this offset is actually was not accompanied by any seismicity. There's no swarm, so it's just like the earthquake actually just shifting the ground, or the instrument that's on the ground. And it is accomplishing that similar kind of work, but it's doing it without having to inject any kind of magma anywhere. So it's still pushing the ground to be tilted further away from the center here. Easier to see on a long-term pattern though. So here's a 1 month lava depth. You can see there's that kind of draining phase, and here we are kind of flatlining at the bottom. And there is our last month of tilt. So the last week we showed you guys was basically this section right in here, with that offset jump right in there. So I'm going to zoom it in here. And that, zoom, here we go. And you really can see that this baseline level there, we put this peak back to here. The tilt really hasn't changed off of more or less this baseline back since, what is this, about the 13th of December. So it's been a couple weeks since it's been more or less at the same level in a shallow region here. It's deflating and inflating, going through these cycles as usual, and getting a little bit of offset. This is pretty different than the last update we did on the 15th, where we saw the trend looking more like it was inflating in the shallow regions. So magma is likely still coming in, but maybe it's not quite reaching the shallow regions as well as before. And maybe that's why we're seeing the earthquakes building up at those deeper levels. Enough that it's causing this occasional pop-up where you see it accomplishing similar work, not by the tilt going up gradually, but being flat and then having a little jump and then coming up a little more here. So still adjusting the surface to the changes underground in a slightly different way there. Also not alarming. And more evidence of this lack of connection to the surface here is being shown by the declining SO2 emission rates. A couple weeks ago, it was at around 190 tons per day, and most recently down around 150 tons per day. A small difference here, but in the grand scheme of things, we're moving back towards that zero line, right? And this is a part of that trend we've seen for most of the last year here, where a year ago we were getting values up in thousands of tons per day, declining gradually over that whole last year. GPS at the summit, north to south across Kilauea caldera, is still showing that positive slope here. It's still rising, meaning the sides are still getting further away from each other. The distance is increasing. That's what this rising trend shows. He's noted occasional little adjustments where it wiggles and things can happen underground. This was an intrusion we had back in September. But the overall pattern is still the same here, right? And it wouldn't be surprising to see more of these adjustments like that one and further intrusions underground and potentially leading to new eruptions, not necessarily out of the same pit in Kilauea caldera of Maunaloa, but anywhere in a caldera could be fair game if it were to pressurize long enough and let that previous pathway harden sufficiently there. So this is one of the points of evidence showing magma still coming in. This is similar to Mauna Loa in that sense, right? But unlike Mauna Loa, we're getting the earthquakes popping up as well. So earthquakes here in a second, but just to complete the story of the GPS, since we're concerned about the East Rift Zone and the habitation on there, at the Middle East Rift at Pu'o'o, you're still seeing the opposite pattern. The sides of the rift zone still getting closer together as the whole thing is sagging. Magma is not going in there at the present time. And it has gotten in there recently, prior to 2020's eruption, and it being in there is not sufficient for it to move towards habitated areas in the lower East Rift, but it is a prerequisite. So that's kind of one stage further towards that state where it could do that, and we're not even there at this point in time. So that's really not on the radar. It's not a major concern, given the history that we know, right? And as always, we'll caveat that with the fact that it is nature. We don't have the full history and knowledge of how it works 100%. Maybe it uses the deeper pathways. There's other things that can happen funny, but we're not seeing sign of anything like that happen. So turning to Kilauea's earthquakes, here is that plot I showed you for the whole last year of earthquakes. And with this rise here, and 3 out of the last 4 weeks evident, very slight rise. Here it is zoomed into the last month. So you see that's not one continual rise up, it's coming in these pulses. So you see there was a pulse that occurred between 4 and 3 weeks ago, there was a pulse that occurred between 3 and 2 weeks ago, and there was a pulse that occurred within this last week here as well. And so it's building up pressure and then moving, pushing around, and that's how it's adjusting underground. And this might be the most useful plot, this last week of earthquakes, and this is plotting a lot of that smaller seismicity, which is why I've always liked these plots. And now you can see here this area of activity underneath Kilauea summit, right? So these earthquakes are colored by depth, and so the reds are the shallows. Let's go here. The reds are the shallows, orange 0 to 5 kilometers, yellow just below that, green, blue, purple is the deeper stuff you see less commonly. So a few of these deeper green, blue, purple, green and blue ones here, but most of it's in that intermediate shallow zone, and you can see it's activating likely underneath Halema'uma'u and areas of this upper southwest rift connector as well. Certainly get a little bit in this upper east rift connector, but it's not really come as far down the rift zone to other areas. So the Pu'o'o tilt meter is all the way over here. So we know for sure that this part is still sagging. And because of this bend in the east rift zone, likely what we see is similar to the past, where you see this activate starting here, and then eventually as it builds pressure, the pressure migrates to the bend. And if it gets enough, then it can, at that point, work its way around, and then your system's pressurized towards a more imminent eruption of Kilauea. So we haven't seen that yet, and that is something we did see prior to activation December 2020, and also prior to the activation in September 2021. So till we see that, does not look like the reactivation of Kilauea is imminent. However, the fact that you're seeing this kind of pattern and not the nothing that we saw in Mauna Loa does show that it's building its way towards that. It's not sitting statically underground. So that's the earthquake plot here for Kilauea, and thought we'd wrap up the Kilauea part of it with just recapping the USGS updates. Really not a whole lot has changed. There's been no tremor. They talk about how there were overturns of lava back 3 weeks ago. The update from December 20th. Notes that there was an overturn occurring on that morning of the 20th. Also occurred on December 17th. Also December 14th and 15th. So those are those individual episodes. And nothing really since then. So that's and then no activity in the East Rift Zone as well there. So that's the Kilauea update. Let's just show the most recent one from this week as well. Tuesday, December 27th. Still not erupting, no other significant changes. Slight uptick in seismicity. Earthquakes in the west and south Caldera disturbed the tilt meters, creating spikes in the tilt data. Apart from the earthquakes, summit tilt meters show very little change since December 22nd. GPS data continue to show long-term inflationary trends. Gas emissions remain low, about 200 tons per day on the 14th. Here. No unusual in the East Rift Zone. So that's all just sourcing what I've just shared with you guys. And let's turn to our gas, right? So gas is the primary hazard for these eruptions, it turns out, and there's not a whole lot of gas coming out now, but as Dane mentioned before, it's nice to set the baseline standard for this. So here's what our VOG plot looks like with very little VOG coming out. They are still putting in 150 tons per day for Kilauea. So you do have a little bit coming in, but it's very little, and it's not going to exceed many of the limits that people have, and it's not going very widespread. However, in a national park and in Volcano Village area, you might still detect this with your very sensitive nose. But if we look at one of our other standards, purple air, to load fresh and show you guys what background baseline looks like here. So all these greens, you see there's a station up here in that east side of Mauna Kea that often shows high. There's a few here in that corner area, that north corner, that still show a little bit high as well. So there are other factors besides volcanic gas, right? Whether it's dust or pollution of some other kind, or whatever it may be, that's the background level there. So that is all the data we have. There's a couple of community things to mention to you guys. One is that the Volcano Awareness Month, coming from January 23, has had its schedule released here. So this is released by the USGS, Volcano Awareness Month. And the programs begin on Thursday, January 12th at Hilo, tracking faults and ground information. There is a program at Ocean View, Mauna Loa Talk Story, on Saturday the 14th, 1 to 3 p.m. Kona, there are a few programs happening in Kona. Tuesday, West Hawaii Civic Center at 6 p.m., talking about hazards. Wednesday, a program on Naleo TV, 6 p.m., Mauna Loa 22 eruption and response. On Thursday the 19th, Hilo, geochemistry of Mauna Loa. That'll be an interesting one. We've heard lots of questions about that. And then a couple programs shifting to the national park. So on the 22nd, you see there is 2 hikes occurring at Mauna Ulu. Great activity led by Dr. Carolyn Marchetta. Then there are 2 After Dark and in the Park programs on the 24th and 31st. On the 24th, it's Mauna Loa eruption insights, and on the 31st, it's Kilauea summit changes over the last 2 years. And the last one in between is a Thursday the 26th. That's on the Kona side at Pu'uhonua Honaunau, Mauna Loa eruption insights, and staying prepared. So that is the schedule for the Volcano Awareness Month talks. And as it gets closer, we can share week by week the details of exactly where these are going to be. But there's more information here. I'll just leave it at the schedule for now. One other thing to note is there is another Volcano Watch today, which is titled "Your Job Sounds So Cool. How does one become a volcanologist?" And this is also posted on HawaiiTracker.com. This is well put, that there's many different specialties in volcanology, and as many passes you can get there as there are tools of the trade. What are the tools? And that's something we've covered before. The tools are earthquakes, geology, geochemistry, geodesy, geophysics, gas geochemistry, all the satellite sensing aspects of those things. And ultimately, here is their advice. So I'll cut to the chase here. How do I choose which tool to use? Don't worry. It's not necessary to pick a discipline right away. In fact, you shouldn't. First thing is work towards a bachelor's degree, preferably in STEM field. And then you have to go into some postgraduate program, because sadly, gone are the days when we're going to apply to a volcano observatory right after undergraduate studies and hope to learn on a job. Typically, you need a master's or PhD. However, within this field, it's typical that you get paid to go to school to learn and get a stipend with all your tuition paid for, rather than having to pay the school. And that, of course, is a many-year commitment, not for everybody, so there are other pathways as well. They mentioned National Park having positions for other pathways without that whole rigorous academic pathway, and that, you could work with bachelor's or advanced degrees. But all those jobs, science writing, geotourism, ecotourism, all those things, and this here is true. Kind of truth about careers in volcanology and earth science is that they are a labor of love. Volcanology is not a career for those whose priorities are a 6-figure salary, a healthy work-life balance, and early retirement. What it lacks in pay, however, is made up for an adventure and a deep sense of purpose. And I think we can likely share in that as well, right? That's always been the struggle, right? And it's never been a lack of interest, but it's always getting people to understand the importance of it. So we'll talk more about that all of next year, I'm sure. Otherwise, that is Volcano Watch this week. One last final thing, because I know someone may ask about this, and it might pop up because it picks up on it. There is one other update from the USGS that involves the Pacific. That's the Northern Mariana Islands update from just now, from Ahi Seamount Volcano. And just really quickly, evidence for possible eruption submarine of Ahi Seamount continued for the past week. The underwater sensors on Wake Island detected possible signals every day of the past week. So there's a plume of discolored water on December 26th noted by satellite, but no observations indicate activity breached the ocean. No local monitoring stations, so that's kind of as much as is known, and that's the end of that. But since last time there was an update on Ahi Seamount beginning to erupt, it made news all over the country, I would include it here as one last thing as well. So Dane, shall we say some thank yous?
Yeah, sure. First, we want to thank our sponsor, iCare Hawaii, who make sure we keep an eye on Mauna Loa. iCare Hawaii is Hawaii's premier, or Hawaii Island's premier eye care specialist. They do everything from LASIK to cataract surgery to 24-hour or same-day glasses, where you get fitted and get the lenses and all that set up in the same day. They got offices in Hilo, Puna, Ka'u, so those are the areas that we're talking about when we're talking about lava exposure and all that. So you got to be able to see the lava coming to know which way to go. So check out iCare Hawaii, and we appreciate them as our sponsors. And then we also got to thank the County of Hawaii through the VIVI grant program. They have secured funding for us to keep these type of content coming to you, as well as some written articles on HawaiiTracker.com and the Hawaii Tracker Facebook group. If you're watching on YouTube and you're not part of the Facebook group, what are you doing? But yeah, we appreciate the County of Hawaii helping us with funding for that. I believe that gets us through the thank yous. Appreciate the viewers, everybody that tunes in. We could have the best information in the world, and it wouldn't matter if nobody watched. Right? We got to be able to get the information out there. Your likes, subscribe, shares, and all that jazz. Commenting after the video, that does help with the algorithm on the YouTube end of things and on the Facebook end of things to try and get it seen by more people instead of the most clickbaity volcano thing that's viral right now. So we appreciate everybody that tunes in to this type of thing. Like, share, subscribe, and yeah, I'll stop with that and get into some questions. All right. We had one from Killer Bo who asked, can we expect some action from Hualalai? I think it may be the best volcano and not a lot of discussion about it. Well, I don't know about best, but I would put it as the most threatening in terms of potential in my mind, just because it's proximity to Kona, the steep slopes, and all those types of things. But do you want to talk about the idea of expecting action?
Yeah, I mean, it happens infrequently, right? So the last seismic swarm was 1929. Previous to that, there was eruption in 1801. And yeah, it wouldn't be surprising if it were to show some sign of something happening, whether that be an earthquake swarm or put up to an eruption. It's hard to predict it when it occurs that infrequently, right? We talked about if we were to do that same exercise with Mauna Loa and say, okay, it's been 1950 to 75 and 75 to 84, and okay, like it's going to come now, and then we would have waited 38 years and broken a pattern. That's the danger of trying to rely on patterns like that. Mm-hmm. So it could be 150 years before the next time since 29. We could live our whole lives and never see it happen. I do agree with Dane that the exposure, right? The infrastructure and nature of lava flows, the nature of eruptions there, how would they come up from a deep down and don't have the shallow systems that are easier to monitor. The question marks about the science of it, like that makes it feel more dangerous. Whereas,
right,
Kilauea and Mauna Loa, those are the devil in some ways, right?
Right. I mean, for Mauna Loa, we're just talking about like, oh yeah, there's a bunch of limitations due to the advancement of technology since 1984. We're talking about 1801. We don't have a good records type of thing. It's just like it's a different age entirely. Like usually the historical cutoff is for the volcanoes on Hawaii. It's like something like 1840, 1843. Sometimes you see thrown out there. Anything before that, you really don't know. You really don't know. And even when you get back to 1850s, it's still really hard. You're just working with snapshots and snippets of information and trying to piece together a puzzle, not knowing where all the pieces are.
Yeah, Kilauea is still the most likely to erupt the soonest. Mauna Loa next,
Yep.
and then Hawaii.
Yep.
Possibly after Kilauea, Kanaloa, Loihi, right? So yeah,
Right.
it's interesting to talk about, and we can talk about it some more. We can we've talked about for a while doing more in Hawaii, but it's hard when Kilauea is ramping up and Mauna Loa is ramping up. So maybe if they stay quiet here the next month, we can put that on our menu here.
Right. Yeah, I mean, I'd love to talk about it more, but good question there. Mike comes in and asks, why does Kilauea erupt so much longer than Mauna Loa? So we have the eruptions on Mauna Loa, typically 2 to 3 weeks. Kilauea, they can go years and be the same eruption. Is there thoughts on why that is?
I don't think I have a conclusive answer. I don't know if anyone has a conclusive answer, right? But you can look at the patterns that do exist. The most obvious thing is Mauna Loa is much bigger, right? So if Mauna Loa moves a little bit over a much bigger area, then it creates a much larger room and change in the underground dynamics than Kilauea. So Kilauea can move a good amount as well, especially when you see the big South Flank earthquakes. That's when it does its biggest action, right? Like we saw in 2018 and 75, leading to the whole East Rift era of Kilauea. But really, it's an open question, right? Why does it erupt so much longer? Why? I mean, you could lump into that. Mauna Loa's. Why is Mauna Loa so much shorter, and why does it have that really distinct pattern from the summit to the rifts that occurs just about every single time? Right, whether it's over one eruption or a couple or more, it's something you don't see Kilauea go summit and then the summit turns off and it goes to the lower East Rift every time. It's not how it works, and that might also be related to that similar pattern process and size of the thing.
The way I've always thought about it, and you tell me if I'm wrong here, is just a lot of these are they come from the aging process and them being different in different process or different stages in that aging process, where you just see the different patterns of that stage, something along those lines. And there's a lot of stipulations that come about from those stages and in just development and life cycle.
Yeah, and yeah, so I think that there's definitely something to that. I mean, the longer you have, Mauna Loa's had longer to develop, but I think the geometry of it is also important, right?
Right.
It was able to. It has a relatively straight. There's a little kink at the summit between a northeast and southwest rift, but that's pretty. Really, what is that? 150 degrees or something. It's not a whole lot of change there, right? So it's a fairly linear feature. It's a big mountain. It's dominating the whole landscape. We've talked about Kilauea's East Rift has something like a, what is it, like a 40 degree, 50 degree bend in it already?
More. I mean, that
much more.
Pretty, yeah, that thing's absurd.
Much more. That's a whole different character of how it could connect rift eruptions and summit eruptions because of that. That's kind of one part of it. But I think, to kind of pull back to that paper that showed the hotspot zones of connection, there's probably something to do with the actual pathways up too, right? And the pathways up develop over time. We didn't get into the details there, but they discuss how those pathways likely had to have time to develop, and the volcano is moving and
so
having stress in areas so that the fluid pathways concentrate into almost like little rivers underground of magma that feed each volcano. And so for that to occur, the volcano is going to be old enough. They don't see that under Loihi, Kamaiahua, Kanaloa, only in Mauna Loa and Kīlauea. So there's something to like the actual pipelines coming up to and how open they are and how well they activate and which parts of that web of network is activating and how well does it flow through there. And that all relates to how much magma is coming from the hotspot as well. And I'll end it there and go ahead, Dan.
Yeah, I don't know if this is what you just answered, but because I was trying to think of my own thing here, but the what came first, right, is the question I have in terms of the East Rift Zone, where we see this deep rift connection coming up, right? And we're seeing this in the diagrams coming up from depth and feeding this deep East Rift Zone. So did the rift zone form around the shallow rift zone form around the deep rift zone? It's something that was already basically traced at depth and then translated to the surface? Or is there some other mechanism at play that made it make that bend? Because that's always been a question for me. Is like, why did it just bend like that? What's the bend? What drives the bend? And keeps it driven, right? Instead of adjusting and trying to straighten out, it likes the bend. So yeah, that's my question is about that deep rift zone and what came first, the deep rift or the shallow rift?
Well, so we could use Mauna as really the best example of the youngest volcano we have, still underground, right? It has rift zones, maybe not as well developed, and they're not miles and miles and miles long like Kilauea, right? So you can have the rift zones occurring first, but to limited extent, right? The deep rift is bounded underneath at the bottom by the décollement, that bottom of the volcano that's sliding past. That is the bottom of the south flank. And to kind of cut to the chase and answer your question, it's the south flank moving that causes that rift to migrate, right? And so that brings the whole structure migrating to the south. So the volcano is going to be big enough to have a flank that can move, which if it's not big enough, then it can't do that. And you can imagine Mauna Loa being bigger has a bigger one, and maybe that's part of it too. So I would imagine that deep rift evolves over time as the volcano grows in size and needs to develop a south flank décollement zone, and then kind of all connect. As you pull apart the south flank, then you're essentially inducing a opening in a deep rift as well. That would be how I would theorize it. All theory, of course, right? We're hand waving here. But that's what makes sense in considering what you see at Kamaihua, Kanaloa, Loihi. Right. So that all relates to as well the fact that those pathways develop over time. When you have the south flank moving, that's how you concentrate the magma trickle into little channels, essentially underground pathways that can be those feeder sources. And the reason they say that those have to be fairly well developed, of course, is they're seeing tremor, like in a long period of earthquakes, the harmonic vibration of fluid moving through there. And for that to show up 20 miles above there, right? Do you imagine it's got to be a pretty well developed pathway and not just like a little couple cracks that seem to touch? Right. So once again, over time, you might have that kind of thing develop, right? And so this is the first snapshot. You can see there's a lot more that's going to come from this, I imagine, right? You could now take this data and go and compare that pathway of Mauna Loa and Kīlauea. Why is it different? The ages? How does that relate? The geometry? How does that relate? All that stuff. You can go back and look at timing more easily, right? Okay, now that we can pick out different structures, like, when this one activates, what happens to Kilauea? What happens to Mauna Loa? Is it going this way? Is it going that way? Like, how does it connect? Is it, you have more than one pathway at one time? Is it 3 of them or 4 of them? What about things that are further back in time before this whole swarm, like Kilauea Iki in 1959, that originally came from very deep down as well, but directly under Kilauea, not from this hotspot area? How does that fit into the whole thing? So there's a whole can of worms with that paper I didn't want to open up too much, but those are some of the thoughts that kind of are floating still that we can come back to as we dig into that in the future here. But yeah, all good questions and things to consider. We're really getting into that theoretical of how it all works underground there, and whether it's always been a question like, we see an uptick in Pahala earthquakes, does that mean something for the surface? And the answer, the reason the question gets asked is because there must be some relation there in that data somehow, somewhere, but there's so many structures that maybe being able to focus on 1 or 2 of them individually might give us the answer, rather than trying to get the whole thing as a unit. It's too big a bucket to try to make that correlation. So it's an important progression, important step towards figuring that out, and maybe we can pick some of that out, and that's all I think to come still.
So the paper that we've been talking about, the research that USGS has been working on in Pahala with all those portable seismic stations, this isn't that paper, right?
No.
This is another paper. This is just an entirely different paper. So we're still going to have that big research, paper that they're working on at USGS is going to come out and only expand what we see now. And this research is already pretty, like a lot of the stuff that it wasn't surprising that what we're reading in there, but it's like, great. Now it's no longer strictly theory, where we're just, basing it off of some pretty iffy things. Now we actually have some solid data points to be able to back it up with. So it's came a long ways in that regard. So it'll be interesting to see how far it goes, especially since before it's like Pahala. No, it likes to earthquake. Probably a conduit of some kind feeding the volcanoes. Besides that, don't know. And we get asked about it a lot, but now it's like, hey, we actually have stuff now, right? It's no longer just our theories on it.
Yeah, well, I mean, it's never been just our theories. It's always been everyone's theories. You know, it's the basis of the whole the scientific outlook on it, based on everything we know. But yeah, to kind of put it another way, what they've done with is use the same data we've always had and just cleaned it up and analyzed it and able to kind of cluster it using the deep learning algorithms, right? Whereas what's forthcoming is new data from new seismometers, new installations that are going to be, going to give you different angles and therefore different resolve different things underground. So that's still exciting to have that upcoming, and whatever data comes out of that effort could then also be treated like this data that was cleaned, to give you that higher resolution of vision, and then all work together, right? So it's only going to get better. So it'll actually build on each other, even though they're coming from different angles to try to address the issue here.
Right. We have a $20 super chat from Scott Get Ed, who says, thanks for your persistence in keeping up with things. Hawaii Pod, appreciate the support there, Scott Get. And I think we'll end with one last little question here. That's cool with you. Michelle asks, is the increased earthquake pattern connected with Mauna Loa being quiet? So I believe the increased earthquakes on Kilauea influencing influencing Mauna Loa being quiet.
Yeah, so we've just mentioned it briefly. We've talked about it a little bit before. We don't have many more details on this yet until there's more information put out, or better graphics, and we haven't made our own like GPS maps or anything like that. But because there's so much presentations coming up here, the AGU just occurred this past month, and next month being Volcano Awareness Month, we expect all those plots to be shared, so we'll share them as they come up. But the bottom line is that it was Mauna Loa that affecting Kilauea, right? So Mauna Loa was swelling and quaking itself, and then once it erupted, the pressure that built underground was relieved. The volcano began to deflate, right? We showed you on the plots how that, like, the drop in vertical and a drop in the spreading occurred, and that basically, the way I read it in our description, was it made more elbow room for Kilauea. Kilauea's got more elbow room all of a sudden. So underground, right? If Kilauea is like coming out at the top of its head, it's got more room down here, so it's spreading out in this area, and less is coming up to the surface. So I
had a much more simple analogy, because we were saying, or I was saying before, Mauna Loa likes to bully Kilauea. So it's like, all right, so what happened here? Mauna Loa stopped bullying Kilauea, so Kilauea got in the lunch line. It had room to now, type of thing. It's no longer getting pressed up against the wall. So it's taking advantage of that little bit of room.
Yeah, so I think it's connected. Mauna Loa's eruption, deflating its volcano, and then Kilauea's surface activity dropping off, and then shifting to underground, deeper to earthquakes, right? It's not like any less magma is coming into Kilauea, it's just redistributing it in a different way there. So yeah, we can leave it at that, and we'll wait to see what other, it's easier to explain that when we can show the GPS arrows, which is why I said that earlier, but I'll have to share that when it comes out in the new year.
Yep. All right. Well, thanks everybody for joining us. We'll try and be back next Thursday, 5 p.m. Hawaii Standard Time. That is the normal time we go live, unless something happens like an eruption. If that does happen, we will go live. But barring that, we'll see you next week.
Yeah. Happy New Year, everyone. Happy holidays. Thanks for your support. Thanks for tuning in, sticking with us. And it's been an exciting year. We're glad it was not a destructive one volcanically here, and hope for more of the same in the future, and we'll be here long term covering Kilauea, Mauna Loa, and anything else that comes up volcanically. So mahalo once again.
Yep. All right.
From HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.